he's on it too. My mom's always freaking out about feces and yeah, well, especially since he's 8, so he can't regulate his emotions. So like, neither can I. That's true. We are. I was happy today. Wait, no. This was nice.
Can I take that chance?
Yes.
I'm not going to put it on mine. I'll do it too, but I think I'll put it on my I really don't want to. I don't even know. Oh, I don't mind. Yeah, but have to get brought up. Because I don't want to go. I feel like it's our last year. I'm so much like, wait, should go? That's why I feel like I don't know. I want to go home and see. And when you started rolling, I just don't want to do. And I was like, so you killed your battery. One more day feels like I think you had it on my birthday. She's got it.
All right, ladies and gentlemen. So, to begin today, we're going to show you how to do conversions, and we're going to give you time to practice them today. Those are what is going to be on your quiz tomorrow. There are 4 problems on your quiz tomorrow. You will need to identify what substance you are talking about through its formula, and then you will have to convert either from particles into moles or moles into particles, from moles into mass or mass into moles, and from mass to volume to moles or moles to volume in 1 2-step one. Yes.
You know the worksheet, it's saying crap like, what is the greater amount? Like, do we have to compare them or
Well, that's what a mole allows you to do.
STP or?
Well, STP just means standard temperature and pressure, and all gases need to be at it. So, and if they're asking you which is the greater amount, well, mole is amount of substance.
You're probably gonna have to help me.
Why? Which is bigger, 2 dozen eggs or 3 dozen eggs?
2 dozen, but I still don't
2 dozen eggs is bigger than 3 dozen eggs?
Oh, see, exactly. This is why I need help.
Well, then you're going to have to find the time to come in and see me. Or you're going to have to ask me when you have 4 times today. Okay? But again, don't make it more difficult than it needs to be. Amount of substance, if you have 7 of these and 8 of these, which one do you have more of? The one that you have 8 of. That's not a difficult question for you. Okay, ladies and gentlemen, before we get going today, questions about the lab that we did.
Can you do the last one?
Through the last one. What do you mean?
Last question.
What does it say?
I'm not sure.
Then I can't answer it for you. Open it up, find it out, and I will answer your question. Or I will at least guide you in the right direction. So, for the rest, while you are figuring that out, while Cynthia is figuring out what question she actually has for me, open up your EISN and get to slide number 13.
Her question is, what does this lab have to do with the mole? Wait, what does this lab have to do with the mole we have been studying about?
Okay, well, what did the lab have? What is the mole?
Mass.
No, mole is not mass.
Part.
Mole can be related to mass.
It's the particles in the
Which is what?
hold on, I have it written.
What is the definition of a mole as a base unit?
Amount of substance.
Amount of substance. So what we looked at is we looked at an amount of substance in your lab, right?
Right.
But we looked at it in different ways. We looked at it, you can look at amount of substance, okay, which is the number of things that are there. Didn't we calculate that out in the lab? Didn't ultimately the last thing you did for every object was figure out how many were in the bag? That's the amount of substance, correct? Now, when we sell things in the United States, some things we sell by the amount. Name me something we sell by the amount. Okay, we sell eggs by the amount. 12 of them, 18 of them. You can't go to the store and buy one egg. You have to either take a dozen or 18 or some multiple of that. That's being sold by the amount. What do we sell a loaf of bread by?
Loaf.
But that's not.
Bread.
So if you're saying by the loaf, that's what? That's the amount of them. That is the amount of them. Okay? Now, again, you could say we sell things by the amount because, again, everything comes in a package of one. But what is the difference between a 2-liter bottle of soda, a 20-ounce bottle of soda, and a 1.25-liter bottle of soda? They're all ones, but you're really buying it by the what?
Volume.
Put away the food. Thank you. What are we buying it by?
The volume.
By the volume. Ounce is a type of volume. But in a 1.25 liter or in a 2 liter, we're not buying it by the ounce, we're buying it by volume. Okay? So we buy things in this country in different ways. Even if you go to the store and you buy a box of cereal, there are different size boxes of cereal. So what are you actually buying it by? What is the difference between the small box and the large box? What do we actually measure the cereal out when we put it into the box in? That's the question that it's asking you. Now, amount is simply counting them. 1 box, 2 box, 3 box, 4 box. But why did you choose the big box instead of the smaller box? Because there's more something in there. So think about that. Question. Does that?
How does this answer the question?
Well, you got to figure that out. Mole is amount of something. What did we do in the lab?
So we found the amount of the substance.
Okay.
Just use mole.
In the
Yeah, but we didn't use mole, so I don't know why we're asking.
Well,
So what is that
remember,
basically?
mole relates. Now listen. When you have 1 mole of copper, how much do you have?
1 mole.
But how would we measure that in the lab? We wouldn't go into the lab and say, okay, here's a bunch of copper. There's 1 mole of it.
5.
So the mole relates to
Right.
the mass, the grams. Okay? And if you know the amount of grams of something, you can figure out how many moles of something there are, right? So we can go from something like mass to amount of that. Kind of like in the lab when we never actually counted what was in the bag. But what did we find out about the bag?
The amount that was
How?
because of the mass.
Because of the mass of those objects.
So we found the amount because we found the mass.
Correct. And that's the same thing we do with the mole. We're not going to go in the lab and grab a bunch of carbon and go, here's 1 mole of it. No, you don't know. You're not going to count them out. You want to count out 6.02 times 10 to the 23rd atoms of carbon? Hell no. So what do? We measure its what? We measure its mass and we are able to convert it. We measure its mass and we are able to convert it. But the mass gives you the amount. You go to Fleet Farm and you buy a box of nails. The box is 1 pound, 3 pounds, 5 pounds. Do you have any idea how many nails are in there? Yeah, they do. They know exactly how many nails are in there. Because they know how much a nail weighs. And on the box, it'll say 1 pound box, approximately 105 nails. 3 pound box, 315 nails, or whatever it is. But they're able to give you an idea of how many are in there. Now, did our numbers in the end, when we were figuring out the amount, did they come out to exact whole numbers? No. Why? Well, we based it off of the average mass. Is every object the exact same mass? No. But we should be able to get close enough if we take a big enough sample to be able to get close to it. Questions? Rocio, I did put an alternate lab in for you. If you look at it, I put some information in there. If you have questions, please let me know, okay? Questions? By the end of the day today, the lab needs to get turned in. This, ladies and gentlemen, is everything we're going to do for the next couple days. This is all of it. If you are going to go to the mole from any of these three conversions, any of these three, if we are using particles, the magic number is 6.02 times 10 to the 23rd. And if we are going from particles to moles, particles has to be on the bottom. Why? Because it'll cancel out. And then we will be left with the unit of moles. But if we are going from moles to particles, now particles goes on top, moles goes on the bottom. Why? Because if we're in moles, moles will cancel, we will be left with particles. If we are going from moles to volume, we put 22.4 liters over 1 mole. Why? So that moles will cancel out, we will be left in volume. Now, again, ladies and gentlemen, your question at the start, Ava, 30 liters of gas or 20, which is a larger amount? 30. Guess what? That's going to mean there are more moles in the 30 liters of gas than there are in the 20 liters of gas. But the only way we can actually compare that is to get to moles, because moles measures amount. Volume says it's taking up more space. Okay? It's taking up more space. When you convert it into moles, if you have a larger amount of moles, that means there is more of that substance there, because moles is amount of substance. Questions? So you want to go from moles to volume. This is the conversion you will always use in this entire unit. You want to go from volume to mole. This is the conversion you will always use in this entire unit. Why? Because the only number we will use for volume of a gas is 22.4, and the gas must be at what? The gas must be at STP. Now, I am telling you right now, on questions, I will say the pressure is 760 millimeters of mercury and the temperature is 0 degrees Celsius. Guess what that is? That's STP. Those are the conditions of STP. STP stands for standard temperature and pressure. We learned that in Unit 2. Okay? We learned that already. Okay? Now, here is the only thing I can do on a problem with volume that could make it slightly more difficult. The only thing I could do with this is, instead of giving you liters, I could give you milliliters. If it's a small amount of gas, I'm not going to put 0.0025 liters. I'm going to give it to you in milliliters. So a conversion that you are going to need to know that we learned in Unit 1 is 1,000 milliliters equals 1 liter. Now, I don't care if you can do this conversion in your head. So, for example, 250 milliliters equals 0.250 liters. You can do that in your head absolutely fine. You need to set up a conversion factor and do it absolutely fine, but you got to get it correct. And I will give you credit for whichever one you do. I expect you to be able to do that in your head. I do. So I will give you the point for making the conversion without showing me anything, but it's one of the only ones that I will let you do that. If you're going to show me going from moles to volume, you need to show me this conversion factor. And it needs to be set up the right way. Now, if you do the math and you go, okay, I know I need to multiply by 22.4, here's your answer, I'll give you a point for the answer, but that's the only point you're getting. You're not getting the point for showing me how you got there. Okay? So you need to show me your work in this unit. You need to show me your work in this trimester. Questions? This is the only one, ladies and gentlemen, where our number actually changes. Our number changes because it depends on what your substance is. Your substance determines the formula mass. And if we are going to go from moles to mass, oh, good typo. We put formula mass over 1 mole. What is the formula mass? I don't know, because it depends on what the formula of your substance is. And if we change your substance, it's going to change the formula mass. And if we are going from mass to moles, formula mass goes on the bottom. But this is just grams. Grams, that's all that is. That's what we've been doing. Questions? So, if we were to look at it, ladies and gentlemen.
Wait, so the formula mass is what we've been working on for the last couple of days, right?
Correct.
So when we find that, we divide it by 1 mole.
We use it over 1 mole to get from moles into grams. That's how we go from moles to grams. If we're going from a certain number of grams and we want to know how many moles, the formula mass needs to go on the bottom.
So we would like times it and then
Correct.
cancel it.
Correct. Yes, cancellation. So, 1 mole of antimony, 121.76. We've shown you this. We've been through this one. Take the moles of antimony, and we use grams over moles. Why grams over moles? It's the only way moles will cancel out, ladies and gentlemen. Our units cancel out. We now take 6.89 times 121.76. Technically, we then divide it by 1, because that's how you handle a fraction. You multiply by the top and divide by the bottom. I'm not going to put divided by 1 in my calculator, because it isn't going to change a dang thing. There's your answer. The only thing left to this is sig figs. 1, 2, 3, 4, 5-point problem. 1 for the formula, 1 for the correct mass, 1 for setting this up correctly, 2 for your answer, 1 for the correct number, 1 for sig figs and unit. Questions? So 4 problems. Tomorrow's quiz, 20 points. I wonder how. There you go. Now, this problem, we are asked the opposite. We are given the mass. We are asked to find the moles. Still need formula mass. Still need this conversion. Now, we take and put mass on the bottom so that it will cancel. Moles on the top, 2.99 moles. Okay? Now, Ava, the question you asked earlier about amount of substance. This is 2.99 moles of substance. This is 6.89. Which one is more? Please, anybody answer.
6.89.
6.89. So we can find out which there is more of, even though their masses may not be the same. Mass does not tell you which one there is more of. Mass tells you which one there is more matter of in that container right there. These two things. You're fine. There is the exact same amount of things in these two containers. Does that look like the same amount? No. This is much heavier than this. But they're the same amount here because they're the same number of particles here. The exact same. But the only way we can compare that is to get into the unit of moles. The only way we can compare which one there is more of here, which one there is more of, is by getting to moles, because that is a counted number. That is the amount of substance. This has a heavier mass, yes. This has a lighter mass, yes, but the same amount is here. It's not based on mass, it's based on moles. Same amount here. Questions? Okay, so this is the problem that we left off with the other day. A sample of nitrogen gas occupies 18.6 liters at STP. How many moles of nitrogen are present? So, 1 mole of any gas equals 22.4 liters. 1 mole of nitrogen gas equals 22.4 liters of nitrogen gas. So if we have 18.6 liters, we are going to take this fact and make a conversion factor out of it. We are going to put part on the top and part on the bottom. How do I know which to put where? I want my units to cancel. The units are liters here. The units are liters here. They go on the bottom. 1 mole over 22.4 liters. Now we can figure out how many moles of nitrogen gas there are there. There are 0.830 moles of nitrogen gas. We can go back and compare this amount of nitrogen gas to the last question's amount of potassium chloride and figure out which one there's more of. Because we are in a unit that we can compare the amount of which is the mole. Yes?
Where's the STP at? Where do you put that?
You don't.
So
But it's the conditions the gas must be under for you to do the problem. It has nothing to do with the problem right now. Nothing. Other than this relationship is not true if it is not STP. This relationship, 1 mole of gas equal 22.4 liters, is only true if your gas is at STP. For this entire unit, your gases have to be at STP. Have to. You don't have to worry about it. Okay? Now, next unit, they won't be at STP. We will have to worry about it. But for now, if you're converting from liters of a gas to moles, it will be at STP. Otherwise, you cannot do the problem. And I'm not going to give you any that you cannot do right now. Questions? We could reverse the problem. A sample of carbon dioxide gas occupies or contains 3.79 moles at STP. How many liters of space would the gas occupy? So again, 1 mole of gas equals 22.4 liters. Carbon dioxide, carbon, 1, dioxide, 2 oxygens. 1 mole of carbon dioxide gas equals 22.4 liters of carbon dioxide gas. You do not need to show me this in a problem. You need to know how to use this. You do not need to show me this. Why? Because you're either going to put it correctly in here or you're not. This becomes this. And the reason the mole is on the bottom is because moles are here. If you flip these, your units don't cancel. Your math is not going to work out. There is only one way to put this conversion so that it works. And that is what you see right here. Questions? Take 3.79 times 22.4. We get 80.896. 80.89, 3 sig figs. This 8 has a 9 after it. I round it up to a 9. So 84.89 becomes 84.9 in 3 sig figs. Questions on that? By the way, how many sig figs have been in every one of these problems so far? 3. If you want a safe bet, put your number in 3 sig figs. Yes, you may lose 1 point out of 4 or 5 problems, but you'll only lose 1 point if you don't want to have to worry about sig figs. You should be able to do it, but again, it's 1 point in a 5-point problem. Questions? Okay. How many atoms are in a sample of 5.565 moles of gold? Okay. So now, 1 mole of a sample equals 6.02 times 10 to the 23rd particles. Now, I will tell you, this gets just a little bit tricky. Why? Because it depends on what particle is making up your sample. If your sample is gold, gold is a what? Element, molecule, formula unit. Which is gold? Element, molecule, or formula unit? An element. What is the smallest piece of an element? An atom. So the particles are atoms. So I can say 1 mole of gold atoms equals 6. Excuse me. 6.02 times 10 to the 23rd atoms of gold. Atoms are the particle. That would not be the case if we were talking about table salt. It would be formula units of table salt. That would not be the case if we were talking about sugar. It would be molecules of sugar. Now, yes, this molecule is made up of atoms. But if we're talking about sugar, the smallest piece of sugar that is still sugar is the molecule. If we are talking about the smallest piece of salt that is still salt, it is the formula unit. Okay? So, we're beginning with moles. Moles here, atoms here. Which one goes on the bottom? Moles. Only way units will cancel out. 6.02 times 10 to the 23rd. Take out your calculators, ladies and gentlemen. Take out your calculators. Now, this is 100% your choice, ladies and gentlemen. There are multiple ways to input anything into your calculator. I am going to show you the way you should do it. If you choose to do it another way, that is up to you. But if it gives you the wrong answer, that's on you. So, on this calculator, and if you have a different calculator, in a few minutes I will come around and you could show me your calculator and I will show you where to find the buttons you need. The way we enter this number, 6.02 times 10 to the 23rd, any number in scientific notation into your calculator is this. 6.02. Second EE button. The E means times 10 to the, thank you. It takes the place of it. Do not do 6.02 times 10 EE because you have just entered 60.2 instead of 6.02. This takes the place of the times 10. Now other people will be like, well, Mr. Brand, I'm just going to use times 10 caret key. You can do that. However, if that is part of a string of values that you are putting in, your calculator treats each one of those things differently. It says 6.02 times 10 to the 23rd power. This says this is all one number, ladies and gentlemen. 6.02 times 10 to the 23rd. So after the EE, you put in the power. That is how you enter a number in scientific notation into your calculator, ladies and gentlemen. Is there anyone who does not have a Texas Instruments calculator who cannot find their EE button? Because on some other calculators, it may be different.
I found it, but it gave me like...
It might give you times 10.
It says times 10e to the 23rd.
Let's see.
I'm putting my calculator to use.
The only way I could...
I mean, I did it right the first time.
As long as it's coming out with the right answer, the answer that I'm about to show, that's fine.
I did it right.
That one I'm not very familiar with because I can't afford a calculator like that. So anybody else?
Would we put this like in parentheses times and then whatever number?
Here's the thing. If you enter it this way, you don't have to put it in parentheses.
Oh, okay.
Wow.
So if you put it in the way I am showing you right now, your calculator recognizes this whole thing as one number. Now, if you do the times 10 caret key, your calculator doesn't recognize that as one number. Okay? So, anyone need me to show them on their calculator? Okay, again, my calculators are up here. Please grab them if you need them. Okay? Please grab them if you need them. Now, I want to point out, in a problem like this, KP, it wouldn't matter because everything is going to be on the top. Okay? So because of that, you're doing the same mathematical operation all the way through. Times, times, times.
Yeah.
It wouldn't change. However, if this is on the bottom and you enter it with the times 10 caret key, you need to put it in parentheses then. Okay? You need to put it in parentheses then.
Wait, so then the number we get from that, we replace it with
That's
this, and then we times it times.
So,
Wait,
yeah,
you lost me completely there, Cynthia.
Okay, so after we do this,
Yes.
we replace it with our answer that we got.
Well, what you would do for this problem, put 0.565 in your calculator times 6.02 EE23. 6.02 EE23 takes the place of this number, and then hit equals. And you should get that number right there.
Just take this and then just times it.
You could.
This is still the same.
Well, yeah, because if you put that number in first, if you multiply times this, that doesn't matter.
Okay.
But you should come up with that number. Now, again, I've said this before, I'll say it again. A lot of you are sitting there without calculators, and a lot of you are sitting there without doing the calculation. Good. You better make sure you get it right on the test, because if you don't practice this and you don't know that you're getting the wrong answer by how you're putting it into your calculator, it's terrible when you find out on your test that you're 10 times too big or 10 times too small for your number. Questions? Chances are too, when it ends up coming out of your calculator, it will look like this. Now it says 6.02 times 10, and here's your power. So that's the way your calculator will finish it up. Okay? That's the way your calculator will finish it up. Questions? Okay. 1.36 times 10 to the 23rd molecules of water are in a beaker. How many moles of water are in the beaker? 1 mole of a sample equals 6.02 times 10 to the 23rd particles. Water. What kind of particle is it? Is it an element, a molecule, or a formula unit? It is a molecule. So therefore, 1 mole of water molecules equals 6.02 times 10 to the 23rd molecules of water. We begin with our molecules of water. We are going to take it times 1 mole over 6.02 times 10 to the 23rd molecules. By the way, if you do 6.02 times 10 to the 23rd molecules and you do 1 mole here, I'm fine with that. You don't have to include the molecules, the water molecules and of water here. Do not abbreviate molecule, M-O-L. Correct. Okay, don't abbreviate molecule, M-O-L. Now, you end up with 0.226 moles. If you're punching this into your calculator and you're not coming up with the number I'm giving you, you are not putting it into your calculator correctly, and you and I need to talk to correct that. And we can do that in a couple of minutes. Questions?
Wait, what in the bottom we're dividing?
I'm sorry, Cynthia, what? Did you say something? I'm sorry. And I think, KP and Ava, I think I kind of heard what you were saying. You may end up with a number that is close to this, but a little bit different.
It's like 0.00001 off. Would you mark me off for that?
No.
Okay.
Again, we're not arguing over thousandths. We're not arguing over hundredths. And especially when it comes time to formulating a mass. If you use numbers that are slightly different than are on your periodic table, your final answer and mine may differ slightly. Like you say, 0.001, 0.002, something like that. That is fine. And please remember, if you don't round correctly, it's going to be a wrong number as well. Questions?
Do we do sig figs? Oh, yeah, sig figs.
We always do sig figs. Always. But again, how many sig figs in that number?
3.
3. Everyone I've given you has been 3 sig figs so far. Am I saying there's not a chance one could be different? Yes, it is a chance. 90% of the time, 3 sig figs will get you where you need to go.
Wait, what number? 1.36.
This is the only thing that had to be measured in this problem. So this has 3 sig figs in it.
So we don't count those.
No, you never count anything after that. Just like with a final answer in scientific notation, that part shows the sig figs. Questions? Okay, best thing to do is to practice. So you have got until about quarter after, ladies and gentlemen, then I need to show you how to do 1 2-step problem. So the worksheets are there. I would get started on them. I would partner up. I would get in a group of 3 if you want. Pull 3 desks together. Please don't go back in the lab because I have things set up for my other class. But pull as many desks together as you want and work on it, ladies and gentlemen. And when you have questions, I will be happy to come over and help you. And if you're not sure how to put something into your calculator, now would be a good time to show it to you. Okay? That's all I'm over here for. I thought you had some earth-shattering question. Yes. Okay. So here you're going to make observations of these objects. So there's your nails, there's your marbles, there's your nuts, there's your thumbtacks, washers, and sorry, these were paper clips and nails. So they're in the same order they are here. You just need to try to make some observations. And I know this is hard because you're not seeing the objects, but you got to do it based off of the picture. Then we took and found 50 of them in a container and found their weight. So you need to take this number divided by 50 to get the average mass for each one of these. Okay? So why don't we, well, I'll give you the rest. So here we found the mass of a large bag of them as well. Okay? Here's the mass of the bag. So to find the mass of the sample alone, you're going to take the mass of the bag of sample minus the mass of the bag. So these two numbers subtract. That'll get you this one. The average mass of one piece is the table that you just did here. So the values that you get here, you're going to put them in here. Yep. Because what we're then going to do is take and find the number of sample pieces by taking the mass of the sample alone, this number right in here, divided by the number that you got here. This is the one number here where it should be a whole number. Because there should be like 75 of them in there, 100 of them in there, 200 of them in there. So this is the one spot where you round to a whole number. Okay? And then the questions, take a look at those, and if you need help with that, we'll do that afterwards, but you got to get this done first. Okay? Okay? So I would start with the mole conversion. That would be the best place to begin for what you're going to do in the month. Okay? The mole conversion worksheet is the one that you want to begin with for tomorrow. The one where you were doing formula masses. Hopefully you've done those. Hopefully we've been through that enough. Do the molar conversion one because that's what it's going to be like on the quiz tomorrow. Yes, but I think there was someone before that. These are okay. So do a few of the mass ones, then move on to a few of the volume ones, then a few of the fun.
I have a question when I get back. I just need to take a little chill.
SCP is the don't worry about that. Ignore that. Ignore that. It has nothing to do with the problem, but I have to put it in. They're all online already.
Yeah, they're all
online already. So you're going from 3.91 moles into liters. Start out with 3.91 moles. What conversion factor do we use to get from moles to liters? No. Ladies and gentlemen, to help you, I will leave this up there for you. This has every conversion you need right now. Every one. Ask yourself, what am I in and what am I going to? Am I in grams going to moles? Am I in moles going to volume? If I am, follow the blue arrow and use this conversion. I have no problem in the world if you want to write this on a periodic table, ladies and gentlemen. No problem at all with that. Yes, it has to be grams. Volume will be liters.
Particles, and you can use like molecules, atoms, things like that. This formula.
I think that's grams.
Yeah,
you don't want to.
So if it's an ionic compound, it's one of those ionic compounds that we gained at the very start of the trimester, that's gonna technically be a form of the So in these problems, there's either gonna be a 1 on the top or a 1 on the bottom. I don't worry about what. Multiply by 1 means nothing, divide by 1 means nothing. So if the
check
number
the-
that's not 6.02 on the top, you multiply these two together. If it's on the bottom, you divide it. Go back. The reason mole is on the bottom here is because I'm in the unit of moles. Go to the next one. The reason mole is on the top here is because I'm in the unit of molecules, we need molecules on the bottom. And since I'm trying to get to moles here, moles has to be on top. The unit that you're trying to get to is always on the top of your conversion. If you're trying to get to liters, 22.4 needs to be on top. If you're trying to get to particles, 6.02 times 10 to the 23rd needs to be on top. If you're trying to get to grams, formula mass has to be on top. If you're trying to get to moles, moles has to be on top, and then those things need to be on the bottom. Correct. But you're either going to be given particles, you're either going to be given volume, liters, or you're going to be given mass. Then, yes, they go on the bottom and moles goes on the top. Nope, I will not. That you can have written down on your periodic table though, or on your solubility chart, you can use it. Okay? Okay, how do you get that to the mass? Okay, first of all, that's not the formula for sodium hydroxide. NaOH. I understand, but folks ain't gonna cut it. Second of all, you need to take this number and use a conversion like this, but with the correct mass on top, to get to the grams. Why not? Well, this is not equal to 1 mole for NaOH. Well, I understand that, but I'm just saying, you've got to write the correct formula first. So if you don't write a correct formula, you're gonna end up with the wrong formula. Okay? Don't worry about STP, it's talking about liters. So what is the number to go into volume in liters? Look at the board. What is the number that we always use to go into or out of volume? How many liters? Yep. So that's the number that you're going to put on top. Don't worry about the STP.
Right there.
You can write it on your periodic table or you could write it on your solubility chart. Certainly. Hang on. I gotta go over my superior. Yes.
If you got, like, do I have
I did not understand why you're doing this type of. So I need you to make units out of here. Now what I would do is I would give you a point because you're correct, you get the correct one. But you lose a point because you don't have this over 1 mole, so that I can see the units canceling out. And then you would lose a point here because this is not in 3 sig figs. It is the correct unit. But it's not in 3 sig figs. I want you to show me how you're getting from one thing to another. Why you would multiply by 40, I don't know, unless you say, well, because it's 40 grams over 1 mole. Okay? Okay? So yeah, I do want it like the slides I've been showing you. Yes, yes.
I know.
Purple or green? Come on, make a decision.
You are doing that absolutely correct. This number though needs to be in 3 sig figs, and this needs to be grams by that. And then your final.
Because when you have to find the formula.
What you're setting up and what you're doing is correct. Yes. Okay, you got it. Well, what are you trying to get to? What you? Grams. Then for grams, that's mass. We use formula. Have you written out the formula mass yet? Then figure out the formula and find the formula mass.
To do the exact same thing as doing.
You don't know how to write a formula for sodium hydroxide? This is the formula for your compound. Write the formula. This is the name. Write the formula. Sodium hydroxide. What was that
Yeah,
formula?
it's 15 grams.
You multiply all the numbers?
No, you add them. Oh.
I will go back to this in a second, ladies and gentlemen. This is what I expect to see on the quiz. I expect to see a conversion factor with something on the top and something on the bottom. I expect to see that these units can cancel. If you write down 6.89 times 121.76 equals that, you're not getting full credit. I don't know why you decided to multiply. Why didn't you divide by it? So again, you need to show me this. And then your final answer in sig figs to get full credit.
What's hexa?
Hexa is 6.
Okay, thank you.
You're welcome.
Yeah, we doing okay? How are we doing? Okay. That is the mass of sodium hydroxide. Now you're going to probably come up with 40 on your current periodic table. Again, that's where I talk about we're going to be a little bit different in masses possibly because I used an older periodic table. But you would have sodium, which is 22.99, plus hydrogen, 1.01, plus 16 for oxygen, that comes up to 40 for you.
So you're just adding
Adding the mass of them. But remember, if there's 2 of them in the compound, you would have to double it before you would add that mass. So, for example, if your formula is MgCl2, you take the mass of magnesium and 2 masses of chlorine. So the formula tells you how many there are. You need to account for that in your formula mass. So in that formula, everything was 1, it was 8.
Mr. Brown, this is what like I feel like I did this, but it's not like but no one did that, right?
That's fine. Now again, yeah, you're setting it up and doing it correctly. Now I didn't check that math in my head for the 215. You understand what I mean there? But what you're doing is setting up correctly. Yes. Correct. Yes. Yes. Absolutely. Olivia, understand what?
I mean, I guess.
Okay, well, let's try to. So start with that number.
On the answer
Oh,
sheet.
so it's this.
Okay, now, dinitrogen pentoxide, write me a formula.
What's
for
that? Greater amount.
Yep. Okay, now, we don't need to do anything with this because we're going from moles or molecules to moles, right? Well, molecules to moles is the one over on the green, right? So we're going from particles to moles. So see the conversion at the bottom? That's what you're gonna use. Nope, you only need to find the grams if for some reason you're going into mass.
C8.
Good.
What do you
So times.
614.
Wait, is the part?
Particles are the molecules in this case because this is a covalent compound, right? So put it in there, do the math, and see if it comes out close to what I got in there. Okay? Okay.
So I got the number that's for S1 and S1 and S6. I got that number.
Maybe your
I don't know what
Well, first of all, you don't need to because it's asking, right? Because this is asking you to find moles, right? What unit are you in?
Oh,
So use the one that goes from liters to moles. No, you're not. You're just getting used to it. You're just getting used to it. You are continuing to let
Information that you don't need. Temperature and pressures for throat. That has nothing to do with the problem, other than to tell me it is in a way, because it says that it's an STP, which means then that relationship is true. But don't let it throw you. It has nothing to do with your problem.
you only get grams.
Not right now. It won't.
Because if you do
It's-
the whatever.
It is and it
over
isn't.
mole times
It's telling us that it's an STP, but I'm telling you, every problem we do with liters has to be an STP. Okay?
How do you want us to set up this one?
Hold on, let me get Nancy first and then I'll. Yes, go ahead. Okay, Nancy, right.
No, because I need to know like how he wants us to set up so we can put points.
That's
Like
like
when we
rock
set it
center,
up.
just age.
I
I told you, you got it right formula.
Phosphate?
Hydroxide is OH.
Phosphate is on the back.
Yeah, add that too.
The formula is NaOH, not NaH. That's sodium hydride. This would be sodium hydroxide. Now recalculate. Yes, go ahead. Okay, what are you beginning with? This is your conversion. That you're doing absolutely correct. But your problem begins with the number that they're giving you up at that time.
Yeah.
So this problem begins with 1.98 grams. That would be the first thing. It can, but in reality, it is the first thing you're doing. So I would list it first, because then it's going to tell you how to set up moles on top or moles on the bottom. Do you understand what I mean? Well, if you write this way first, and then this was actually grams, this would not be the right way. You understand what I mean? Well, I want you to always begin with what they're giving you in the problem. This number. That's what I'm telling you. This is in grams. Grams has to go on the bottom because it's the only way they'll cancel. And if you start with this, then you see where which unit this is, and it tells you which one of these units has to go where. Okay? So by beginning with this, it sets up this part. Okay?
Do I put the number like the subscript in my answer? Or do I just-
Okay, if your answer were to be, because we want moles here, 0.045 moles, I would accept that.
Okay.
Okay, normally, I'm gonna have
Why do I have the one?
Open the door and outside.
I don't know, that I don't know. I didn't know if that was
So
one
you
or
have to multiply everything on the
0.4461. But anyway, that is fine, you do not need the SF6, but I'm telling you, on the quiz, there is a line at the top that says, what is the substitute formula? So you're gonna need to show me that, but it doesn't need to be part of your unit in the answer to get credit. The mole does, not the rest. Okay?
You can see who nominates it. Literally separate.
Come on.
There you go. This one right is left.
Okay, good. So now, that number goes on top. Because that's the formula.
It's part of the
This is easy stuff.
Oh, wait. It only counts when.
Is that what we do?
Or at the end. This is the mass of sodium. This is the mass of oxygen. This is the mass of hydrogen.
Because there's.
That's what formula mass is. Adding up how many things are in the mass of each.
What would be the?
0.0.
It's gonna be so hard to.
You can add 0.0 to make that 36. What unit? What's the other unit? Yeah.
3, 4, 5, 6, 7, 8, 9.
Technically not much. A molecule is a covalent compound. A formula unit is an ion. So technically, if you were to accidentally write the wrong
Basically, yeah.
now, if you were to accidentally interchange those, I'm not gonna take off. Okay?
Sodium is Na.
But that is the particle. It's either a formula unit or a molecule. Now, that is still made up of atoms. See what I mean by that?
Wait.
So water, a molecule of water, should basically atoms. So if you wanna find out how many atoms are in something, you could. But we would first have to look at molecules. And then we would have to look at those three
Grind it up or do you
atoms.
put it in?
Well, that's good. That's a good one.
Right?
But it's cold.
If it's an element, it's automatically going to
So,
it's a matter of what is the sulfur. Now, this calculator is one thing. It's still it's made up of all of those things. I just know one. Okay? So that's what I'm
Maybe you want to.
But again, if they're asking about problems, okay. If they would ask you-
I don't know who won that one.
Where's your how these are?
25.
Everyone is trying to.
I don't know. Nikki, please. Nikki's the
We have
worst.
that one down. We are going.
Yeah,
No.
that's fine. It's fine. Oh, I I know. I swore all. I know. But I am saying it's worse. Like, how are you supposed to prove it?
So why is that? We went on vacation for summer.
Don't do that. It's not my fault.
They all.
I know.
That's
Glasses will be up there.
red.
We're all sitting on the beach.
Then you go up.
I'm fine. I like that.
This one.
Henry and Max.
But then this would have to be good.
Wait, already.
No, why did you ever tell me?
I can't help you.
But that's romance.
Okay, and I'm like you. Most likely to become president yourself.
Because I didn't know what to put.
Best blow up.
You don't always you're going to leaders. You need to do the formula. But you don't need to do the formula.
Oh,
You're distracted.
Who's A then?
Well, they used to add them all. You add the NA, the sodium, and you add the oxygen.
So low here, which ones have the closest masses?
And then after that, so 375.
I want marbles.
You mean
Yeah, sometimes, whatever it is.
I did I knew it.
yeah, you got the same answer.
Which senior did the best?
I added that to 16.
I don't
I got a video from it.
put yourself down for one.
I could have done it. I just might.
Make this a quiz.
Yeah, so now the next question is, look at the which of the three were similar?
I still got to say that. I tried it. Jaffer.
Well,
Jaffer. I don't think that
basically, you
How many?
right, you got 40?
I'm talking
Yeah.
about answer.
Because a lot of
I got 14.
So on some of your samples, they were close in mass. On others, they were close in being.
Oh, okay, I kind of get it. I mean, I did it right. But I still
Right, so go from grams to moles, then go from moles to particles.
Since that's
Then particles to atoms.
Okay. Those are for like.
No.
Even then.
Well, what is
What
this?
you had us right now.
What is this?
Next year.
Does it have keys?
That's only
How many keys?
The keys make up the calculator, right? The smallest part here though is the calculator, right? Well, when you're talking about a molecule or a formula unit, it is still made up of atoms. So when we figure out how many molecules or how many formula units there are, we can then go into atoms by knowing how many atoms we have. We'll show you, get to particles first, and then I'll show you what to do for that. Excuse me? Yes.
So, because it's a diatomic molecule for nitrogen, I was supposed to calculate like into pounds.
Correct.
Grams is math.
Yep.
We mainly try to use formula, I use formula math. Okay, so I didn't get about 1, 2.
2 times 14.
Yeah, that's gonna mess you up. Yep, that's why we say you gotta be careful with those diatomics. Olivia?
14. So it's
Okay. I mean, closer than these three, right?
Yeah.
So, yeah, find the three that are close. Yep. Okay, so which one's greater?
Oh, I did it.
No.
Did you guys?
First of all,
Are you writing it?
okay. Well, the problem is, into that's correct. So here, okay,
Where is?
these begin with this amount and use this equal to 1 mole to convert it. Okay, that's why. That's why. You've got all the right numbers there.
We did just the order doesn't.
What? not a question like that, but it's a straight conversion. Mass to moles or moles to mass.
Oh, okay.
Okay, listen please, because I have seen this mistake a couple times. These are your conversion factors, ladies and gentlemen. These will take something that is in mass and make it into moles or moles into mass. This will take particles and make it into moles or moles into particles. And this will take volume and make it into moles or moles into volume. But you have to begin your problem with what is given in the question. This is where the problem starts. Then from there, you set up a conversion factor based on this. If you try to set your conversion factor up first, how do you know which of these goes on the top and which goes on the bottom? You can't. You don't know. So you have to begin with what is given in the problem. And then you work from there. So in here, the 223 grams is what I begin with because I'm trying to convert that into something else. So this has to be where I begin. Now I can see which way my conversion factor needs to go. Now grams have to go on the bottom because it's the only way grams and grams will cancel. The only way they will cancel. Lizeth, do you have a question? Okay, I'm sorry. I thought you were raising your hand. Okay? And it doesn't matter. Now, here, you don't need to do formula mass. Why? Not asking you about grams. If it's volume, you're going to use 22.4. You're not going to use the formula mass. Okay? You're not going to use the formula mass. Questions?
I have a personal question. I mean by personal, I want to ask you that.
Okay, hang on. Dang it, now I lost my train of thought. Oh, I know. You don't know what you know and what you don't know until you start doing these problems. So if you're not going to practice them, you're not going to know what you're doing right or wrong. And I can't help you if you can't ask me why we're doing this or that.
Okay, so you're in particles? How many atoms are in this particle? This right here, how many atoms are in? Count them. 2 aluminum. Okay, so that would be 6 atoms over 1 molecule. The problem is you have the wrong formula there. That is not sulfate. Now, listen, before you go outside. The good news is the process that you're doing correct. But if you got to get the correct formula. So again, the steps that you're doing, you've got. You're doing them in the right order. You're putting things in the right places. But you got to begin with that correct formula first. Okay? And that's the part that, going to help or going to hurt you. Okay?
Sorry, that's what I heard.